All right, welcome back, Algebra 2. Here we go, guys. We are in Section 4 today, Chapter 3, Section 4, titled Linear Programming. All right, so let's go ahead and make sure that our textbooks are open. All right. There we go. Okay, so there's our page number, and let's jump right into it. Okay, we're going to be doing more graphing today, more shading, because we're still working with inequalities, and we're going to be graphing multiple inequality equations onto one coordinate plane, anywhere from 3 to 4 inequalities altogether. Okay, so here we go. All right, as it says, graphing 4 different inequalities all together. And then you're going to be, of course, still having to do all that shading, all right, that goes with the inequality symbols, greater than, less than. Don't forget the or equal to part and how that changes the line from either dash to solid. Okay, and when you have that full overlapping shaded region where all the shading starts to overlap, and that's the region that you're going to darken, that is now given a title called the feasible region. Okay, so if you're given 4 different parameters, which would be your 4 different inequality equations, those parameters are going to be set based upon what the inequality is telling you. All right, either shade down or shade up. And then once you see all of that overlapping shaded region, that's the feasible region. So if this were to be like a real life example, that feasible region would be the only part where you could actually have true progress. If it goes outside of that feasible region, then it's not possible. Okay. All right. So let's move into the next note here. When 2 graphs cross, so in other words, right there, there'd be a cross, or they touch, or they intersect, that point is called a vertex. All right. You got to make sure that you understand that. We're going to be using that term vertex and vertices quite a bit in this section. So I'll show you through the examples what we're talking about, but you may already understand what I'm saying. You have one graph going here, another graph going here, and right there where we cross creates a vertex point. All right. And one of our last notes here, it's going to be one of these vertices. All right. So one of these points where the graphs are crossing and touching, that's going to produce what we call either a maximum or a minimum objective function. Okay, and that's going to deal with the second example problem that we do together here, where the book may say, calculate the maximum objective function or calculate the minimum. And you only have to pull, for starters, from one of the previous graphs that you've made. Then you're going to look at only the vertices, only those points where the graphs cross or touch. And then also it could potentially be where one of the graphs crosses an axis. All right, so the X or Y axis. All right, so let's move in and see what this all means. Okay, so we're going to graph the feasible region with these following constraints. That's how the book is going to phrase it. So constraints being, listen, only within the given parameters from these 4 equations right here. So we have X is greater than or equal to 0. That's going to be in blue. Y is greater than or equal to 1.5 in green. And then you'll notice these bottom 2 equations here. They're given the black part right there. That's the original equation. All right, so 2.5x plus 5y less than or equal to 20. Then follow right there in yellow. The graph will be in yellow, but I've already rewritten the equation to be in the mx plus b format. So that converts itself to y is less than or equal to a negative 1/2 x plus 4. Okay, so you can see right there that you're going to want to take equations that are given not in mx plus b format and convert them to be then in mx plus b format. And then you can see I did the same thing for the red equation. All right, what's written in black is the original, but then what's written in red over there is now the converted equation. All right, so we have all of our given constraints. Now let's start to graph this. So in blue, we're going to have x is greater than or equal to 0. All right, so let's get blue here. All right, so x is greater than or equal to 0. So basically that means that it is going to be this axis right here. Okay, so we're just going to kind of darken that in blue because that's really what that equation is going to make. All right, so go where x is 0 and then go right through it. So it's actually the whole y-axis. And then it says greater than or equal to. So we are on this side of the line right there. Okay, so that would be the blue equation. Now let's do the green one, where y is greater than or equal to 1.5. Okay, so let's go up 1, then up 0.5. It's going to be a dot right there. It does say greater than or equal to, so that's going to create a solid line. Okay, and then greater than or equal to giving us up. Okay, and you could see, yes, I gave you a couple lines that are on that negative side, but really you can start to see we're only going to care about that overlapping part, which you can see is starting to be created in that upper portion of the graph. All right, so now let's take a look. We have a yellow equation. The y is less than or equal to a negative 1/2 x plus 4. All right, so let's see if we can try to keep that in screen right there. All right, so we have a plus 4. Let's go up 4. 1, 2, 3, 4. Put a dot right there. Then negative 1, down 1, right 2. Okay, so we're going to be right there. And then it does say again, or equal to. So we have a solid line. Okay, let's go right there. And it does say less than. Okay, so we are starting to see this region right here is really now what we're going to start to care about. Okay, so we got this overlapping. So far, it kind of looks like a little triangle. And now let's do the last equation here in red. So we have y is less than or equal to a negative 2/3 x plus 6. All right, so we got to go up 6. 1, 2, 3, 4, 5, 6. We are right here. And then down 2, right 3. 1, 2. Then right 1, 2, 3. Right about here. Okay. And so now, let's see. Okay. And we want to double check this right here. There might be a bit of a discrepancy. That line should cross. I'm thinking I went a little bit off on that red. So let's go back here. Okay, let's double check. So we would go with our x value moving to the right, giving us a negative 3. That's correct. We would then divide everything. That's what my mistake was. All right. So we found the mistake right here. This is our mistake. Okay. So what we should notice is that we moved the 3 over, then divided everything by 2. This should be a negative 3 over 2. And then dividing, that's still going to create a positive 6. Okay, so let's go back to it here. Now we would go up 6. 1, 2, 3, 4, 5, 6. And then down 3, right 2. 1, 2, 3, right 2. You're going to see we're actually on that exact same point. That's our overlapping point. So that is good. Mr. A caught that one. I'm sure some of you guys probably already caught that as you were looking through this video. And then our overlapping portion, because it says less than, you can see we are just right in here. All right. So let's go ahead and notice that this part right in here, guys. This is that overlap. So you see everything in that little region right there. That's the graph, okay? So when it says graph the feasible region with the following constraints, what I really need to see are all of the lines and very clearly that overlapping dark portion, okay? That's right there, kind of in that lower left-hand side. Now, when we move into example 2, we're using the exact same constraints from number 1. So we're not going to use new equations. We don't have to make a brand new graph. We're going to maximize the objective function. And here's the objective function. P equals 25x plus 30y under the constraints that we just had in number 1. Now, we're going to find the vertex. That's, in other words, find the point x and y that makes this equation right here have the biggest answer, the biggest value. Okay, so what we have to do is go and find all of the vertices from this equation right here. Okay, and so one of the vertices, we'll get a, there we go, let's get our marker back. So we have one vertice that is going to be at 0, 1.5. You can see that's that one right there. We're going to have another vertice that's going to be 0, 1, 2, 4. 0, 4, because it's right there. Okay. Then we need to figure out what is this vertice right here. And that's going to be a 1, 2. Yes, here we go. All right, let's erase some of this. We'll clear out some space so we can start to see a little bit clearer here. Okay, so we're going to have a 2, 1, 2, 3. That vertice is right there. Okay, you're going to see that that's the point where we have the yellow line crossing the red line. Okay, and then we got one last vertice that looks like, I know my graph might not be quite spot on, but I'm thinking it's actually going to be a little bit more at x is 3. And yeah, again, that 1.5, that's the green line right there. So 1.5. Okay, and that's actually going to be this guy right here. Okay, so you can see we have our 4 vertices, all right? 0, then 1.5, 0, then 4, 2 and 3, and then 3 and 1.5. Okay, so these vertices are what you will plug in now to this equation down here, the P equals 25x plus 30y. Each vertice gives you a brand new x and y to plug into the equation and see what value comes out. So what you're going to do is you have an equation, 25x plus 30y. Here's a value for x, 0. Here's a value for y, 1.5. Plug those in, see what comes out. All right, well, I can tell you when x is 0, it's probably not going to give you the biggest answer, which means when we're looking up here at 0 and 4, again, it's probably not going to give you the biggest answer because you are missing this whole value of taking x times 25. You're missing that. You're only getting the 30 times the y value. So everything is now leaning towards it's probably the 2, 3 vertice or the 3, 1.5 vertice. Okay, and when we plug those in, all right, let's get the calculator out here real quick. I'm believing it's going to be the 2, 3 vertice. Okay, so 25 times 2 and 30 times 3. That's it. That's the vertice right there. So what that tells us is that it is going to be this vertice right here. And the way we got that, we'll scroll down here, get a little bit more space. is we would take the 25, plug in 2 for x, plus the 30, plugging in 3 for y. That's going to equal 140. All right. And if you plug in all those different vertices, x and y, you're going to find that 140 is the maximum answer that you could possibly get. Okay. So yeah, let's double check. We know that is the correct answer for that one. All right. So that's all I got for you today, guys, in our section 4 lesson. All right. We'll see you guys in the next one.